Recording, and welcome to our big data class for this morning. Might be going back and forth here a bit as I'm just letting all of the stragglers into the room here. But again, welcome. And last time we talked a lot about the Unix shell a little bit more, in particular about the quiz that we're going to be having next week. And today we'll talk a little bit more about that and the homework that is due this week. It's a parallel programming task for getting us introduced to the Twitter data set. Those of you who have taken CS46 with me, you've already completed this assignment, so you don't have to do it, but it's more of a review assignment for everybody else. And we're going to be using this data set quite extensively over the coming semester. So it's good to get our familiarity with it right now. The main part of today, though, is we're going to start talking about this system called Docker. So I'm going to share my screen and we'll get started. And again, all class sessions, it's always important for you all to be asking questions, and it's especially important on Zoom since I can't see all your faces and see get a sense of how things are making sense to everybody or not making sense, as the case may be. And so the best way for you to control the pace at which I am going over material and talking about things is to ask those questions. And you can always feel free anytime to unmute yourself and just directly ask a question. Or if you don't think it's an immediate need to get an answer, you can raise your hand or type the question in the chat, and I will get to it at a good stopping point. Before we get started with the technical material, I just want to highlight some things that have been happening on GitHub. There's been a handful of really great issues that have been posted on GitHub, and so I'm very pleased so far about how you all are embracing GitHub issues to ask your questions. And a couple quick highlights that I want to go over is the first one. We have a pending pull request for our GitHub repo. And in this pull request, it is suggested that, so I just clicked on the pull request link. This over here is called the hash of the commit. If I click on that, it will take me to what's called the diff of the commit, or the difference between what this pull request is suggesting on the right, the change that it is making in green, and in red, the change that it is removing. And so this pull request is specifically suggesting that instead of having a quiz next Monday, we should have the quiz next Wednesday. That seems like a great suggestion to me, so I'm going to go ahead and accept this pull request, merge the pull request, confirm the merge, and now our quiz that was previously scheduled for next Monday is officially scheduled for next Wednesday. And so again, this is one of the advantages of GitHub in general, that you can always, if you see somebody's project on GitHub, you can always suggest a change to it, and that the maintainer of the project can include the change or not include it as they see fit. And in this class in particular, the advantage is that if there's anything about this class that you think should be changed to make the class better, you can suggest that change, and if I agree, I'll make it better. So the short answer is that the quiz that we talked about on Monday on the last class session was originally scheduled for this coming Monday, the first day of in-person classes next week, but is now instead scheduled for Wednesday. So that's the pull request. We have a couple other issues that I wanted to check in with. Let's see. Get to those. Here we go. This first one right here about continuous integration. The main thing that I want to highlight about this issue is just that this issue was originally posted onto the continuous integration repository, which is the repository for the homework. That's a great idea. Normally, if you have a question about a particular repository, that is the appropriate place to post the issue. For this class, though, in order to make questions just more generally accessible to everybody in the class, so that everybody can see the question and the response, it's a little bit better to post questions to the class repo directly, because this is the repo that I've asked everybody to watch, and so this is the repo that people get notified about. So if you do have questions about a particular homework assignment, try to remember to post those into the CS 143 repo. Let's see, also related to the quiz, I posted this issue here about scheduling a review session for the quiz. And based on when people wanted the session to happen, I've scheduled that for this Friday at 2 p.m. And that'll be on the same Zoom link that we normally use. In general, for review sessions and office hours, my plan is to not record them. And the reason I want to not record them is because at different times during the review sessions or office hours, people will be having to share their own screens rather than just me sharing my screen. And that can potentially contain more sensitive information that we don't want uploaded and broadcast and saved for forever for other people to find. So to encourage people to ask more questions during office hours and review sessions, those will not be recorded. So if you want to see what we go over in those sessions, you'll have to either attend in person, or if you can't make it in person for whatever reason, then you have to ask somebody else to take notes for you. Any questions about any of those sort of class administrative things so far? Okay, then there are two other GitHub issues that were more about technical issues that I want us to go over. And the first one is about the Twitter map reduce homework. And so this is something that we haven't fully gone over in class yet, and we'll start our discussion in class today by going over it. Under the class repo, we go to week 1. You'll see that there is no homework folder in week 1, that the homework for this week is a little bit special, slightly different rules than normal. And so going all the way down to the bottom under this homework section, there's a link down here for where to go for the homework. And this is just the homework _ Twitter folder of the class repo. There's a bunch of instructions down here, background about different things in the terminal. Most of this information is stuff that we've gone over in class so far, just applying it to the particular task of analyzing this data set and learning about this particular type of parallel programming called MapReduce. And this Twitter coronavirus submodule right here, this repo, is the repo that contains the source code that you'll be working with. I'm just going to real quickly clone this repo onto the Lambda server in order to be able to answer this this question that's being asked. And so right now I'm who am I? I'm logged in as user test into the Lambda server. And so let's do a real quick git clone. Oops. Git clone of https://github.com/mike/is_Vicky/Twitter coronavirus like this. And maybe I'm being a little bit unorganized right now because I put that into my home folder directly instead of into my project folder. Now let's cd into that, and here's the all the information in the repo. And now based on this, we can answer the question that was asked in the GitHub issue. And in particular, Here, when this command right here is being run, we're getting this permission denied error, that we don't have permission to do to execute this program right here. Anytime you see the $sign in one of these code blocks on GitHub or anywhere else, that means that this is a command that's being typed into the terminal. And the very first thing over here is the actual command itself. So from back over to the terminal, this was the command that's being executed. I'll hit enter and we still get this permission denied problem. I'm going to go ahead and open up this file in Vim so that we can just see what's going on. And this file, again, is located in the SRC or source folder of this repo. There's a number of ways that I can open this file. I could first CD into source like this, and then open the map.py file like that. That's really an ugly thing to do, though. Whenever you're working in a GitHub repo, you always want your working directory. So the result of running pwd, this folder that gets displayed to the left of the $sign, you always want it to be the root of the GitHub repo. The root is the folder that gets downloaded when you run git clone. There's a number of good sort of software engineering reasons for this, but the basic reason is that that ensures that all of the commands are going to be standardized, and that if you see a command, you can just type it in and you know what it's going to do. So in particular, when I have /src/map like this, it's looking first in the src folder and then map. And this command will only work if I am in the root folder, which I currently am. If I'm in the src folder and do /src/map.py like this, then we get an even worse problem that it's not only that we don't have permissions, it's just that the file doesn't even exist. So /src/map.py, permission denied, we're not allowed to run this file. Why are we not allowed to run this file? Well, the reason is because we don't, like it says, we don't have permissions. If I use the ls-l command, that gives me the information about the detailed listing of the information about this particular file. And the information here to the far left contains the details of the permissions, what we're allowed to do with this file. And again, these three right here are the user, the group, and then everybody. And we can see that we have read and write permission, but there's no X anywhere in here, so we don't have execute permission right now. So that's why we're getting this permission denied. We can read it, we can write it, but we can't execute it. In order to execute this file, we'll have to do chmod. So we can do u+x src/map.py. That's one option. That gives the user execute permission. So now we have this X bit over here. And you can see that the color of this file has changed from black to green. And so now if I do /src/map.py, then the program is successfully executing. We're now getting another error message, though, saying that you must also pass in this input path flag, which tells it exactly which file to run on. And but if we did that, then everything would work. So anytime, short answer is anytime you're getting you run a program and you get this permission denied error message, something that looks like this, it means that you don't have the execute permissions set on the particular file, and you need to run the chmod command to get those permissions set. Are there any questions about any of that? Okay. Then back over to the issues. One last issue here coming from about the installing Rootless Docker. Again, we're going to be going over Rootless Docker today, or Docker in general. And there's a great question about some of these different things that the instructions ask you to do, like what is it mean this bin folder and /local/bin and this Docker host and .bash rc file? How does all that fit together? And so we'll start our discussion today of Docker, talking about all of those things. Again, I'm in the terminal over here, and we're doing something sort of totally fresh in the terminal. I want to kind of give myself a blank slate to think about what's going on. And there's two ways to do that in the terminal. One is the clear command, C-L-E-A-R, like this. And if I hit enter, then you notice that the screen clears. But in my terminal over here on the right-hand side, hopefully this is showing up for you in your Zoom window, I have a scroll bar, and you can see that I still have access to all of this previous commands that I've been running just by scrolling up and down. So clear basically just adds a whole bunch of new lines so that you can still have access to the stuff above if you need to look at it, but it's not taking up visual space on your screen. Usually, clear is not the command that I want, though, when I'm kind of mentally resetting and starting a new task. Instead, it's the reset command, R-E-S-E-T. And reset clears the screen, but then it also clears your, basically it resets absolutely everything about the terminal, including like this scroll bar up here. I can no longer scroll up and down, so all of my previous commands are totally gone. And sometimes there's some weird formatting artifacts that happen in your terminal, and reset will get rid of those too. So I commonly run this reset command just anytime I'm starting a new task to reset myself here. And then, okay, let's see. So I'm currently in this Twitter coronavirus repo that I downloaded. I'm going to go ahead and remove this Twitter coronavirus repo. We're not going to need it right now, so let's do rm Twitter coronavirus like this. Again, I used tab completion to make sure I didn't have to type all that thing out, get rid of typos. We get this error message saying it's a directory, so we can't delete it. Recall that if you want to delete a directory, you do -rf at the end. R stands for recursive, F stands for force. Hit enter. Now that directory is deleted. And I'm going to go into the prod folder, CMCI 143 like this, and cd week 1 like this, and there we go. There's good question. Let's see. Yeah, I'm getting a little bit ahead of myself, going straight into Docker without actually answering the questions that that issue posed. So let's go cd back to the home folder like this, and let's talk a little bit more about something called environment variables in Bash. Environment variables. And last time we talked about variables that are not environment variables. Last time we talked about just plain old variables, not environment variables. And we saw that we can use a variable in Bash by doing something like var equals hello world, and then we can do echo var like this. And the way that Bash, or the shell in general, interprets these variables is this gets immediately substituted right here. And in this case, because there's no quotes around var, these quotes get sort of gobbled up, eaten by the shell interpreter. Something like this would have kept those spaces around. Quotation marks keep the spaces. Single quotation marks doesn't even do the variable substitution. There are certain special variables in the shell. And these special variables control the behavior of our environment. One of those variables, which we, the lab specifically, last week's lab specifically asked you to modify a little bit, but you may not have noticed, is called the PS1 variable. And the PS1, PS1 controls what the prompt on your terminal looks like. So the prompt is all of this information over here. And the lab specifically asked you to get it configured so that it looks like mine, so you have a lot of useful information over here. We can, sometimes though, this takes up too much space, especially when I'm deeply in a nested folder. And so sometimes I want to reset my prompt. And the way that I do that is by changing this environment variable. Anytime you have an environment variable that you want to change, you must use the export command. So export ps1 equals what I want the new variable to be. Export ps1, this. And because I'm setting this environment variable, when I hit enter, it's going to change this prompt to be just the $sign. If I change this to, I don't know, something like that, I could make it look like I'm inside of Python. But traditionally, the $sign is used for the terminal. Sometimes if you're logged in as the root user, which is the sort of the admin user on a Linux system, root users traditionally have percent or hashtag as the prompt. But normal users have $sign. So let's make ours back to a $sign like that. And the main reason that I'm bringing this up in connection to the question that was asked is because there is a special environment variable called the path that is going to be particularly important for you as you're getting the Docker containers, the Docker system set up on your account. I'm going to do echo $path in order to see what our path variable is currently set to. And here you can see that each of these is a folder separated by colons. And each one of these folders is a location that the terminal, the shell, is going to look for when look for executables in these folder when you type something on the command line. So when I type in Python 3, for example, and open up Python so that I can run a Python program, in order for the shell to know what to do with this command Python 3, we have to tell it where should the Python 3 command be found. And it first looks in this folder right here. If it doesn't find it, then it looks in this folder. Doesn't find it, then it looks in this folder, and so on until it finds it and runs whatever command it finds. You can always know where the program is located that you're running by typing which Python 3. And so here we can see that Python 3 is located in this folder right here. It is installed system-wide. Everybody has access to it. And so, yeah. So if on any of your systems you typed in which Python 3, you should all get something like this as a result. If we do which pip3, however, you'll see that I get a different result down here. This is the location that pip3 is found in. And it turns out there is also a /user/bin/pip3 command like this. Go ahead and run it. But this is not the one that Python uses or that the shell uses when I type in pip, something like pip3 install YouTube download or whatever it is that I'm installing. Instead, which pip3, Python uses this locally installed pip3 that I have. You all might not have a locally installed pip3 yet. You probably do not, in fact. And so if you on your system type which pip3, it probably will not be this, but will be this result right here. Pip3 comes with a built-in utility to upgrade itself. Pip3 install pip -- upgrade, something like this, will download the latest version of pip and let you use the latest version of pip. You all do not have root access on this machine. You cannot update the globally installed version of pip, because if you could, then you could totally screw up the entire system for everybody else who's depending on pip behaving a certain way. And so whenever you run this command right here, upgrading your local pip install, it's going to move pip into install this pip3 command into this location. And then because that location, echo $path, is the very first thing in the path. That is the program that will be run. So how does all this connect back to Docker? In the instructions for installing Docker, there is a script that it asks you to run. And by default, when you do that, so I'm currently in my home folder right here. By default, it puts all of the binaries, the executables, in a folder called bin in your home folder. And if you're happy with that, then that's okay. You can leave the executables there and you don't have to move them. Personally, I think it's really ugly to have this bin folder just like sitting around like this though. And especially when I already have other bin folders in nicer locations that I could move those files to. And so my suggestion was to take the contents of the bin folder and move it into this .local/bin folder. Recall that dot files, any file beginning with a dot, is a hidden file. So when I run ls, I'm not going to see this .local folder at all. And that way, by moving the executables here, I'll have access to them. If I run docker ps or just docker, for example, it's going to show me that the command works. Something's going to happen. But I don't have to look at the executables. They can just be in a nicer spot. You know that Docker is installed successfully and working because if you just run Docker, you'll get something like this, or Docker PS, you'll get a shorter output like this. If you can run Docker PS and you get something like this, then Docker is installed correctly. The last part of the question was about how do you make these environment variables permanent? And this is also related to a question in the chat about resetting and the PS1 environment variable. So in general, after you've changed an environment variable, how do you make these changes permanent? And the answer is this .bash rc file. So I'm going to open up bash rc in Vim, and then I'm going to jump to the bottom. Shift G, capital G takes me to the very bottom. And down here, you can see I have this export docker host command down here. Docker requires this particular environment variable be set. And so this line right here is going to set the environment variable for me. Anytime that I open up bash, it is going to just run this entire bash script and setting this environment variable for me. On line 80 up here, you'll also see that I'm changing the path environment variable to include the .local/bin. And so this means that I'm not going to have to worry about changing the path environment variable as well. If you followed the lab from last week and updated your bash RC will have this line 80, so you won't have to change this, but it will not have the line 113. This is something that is specific for every individual user, and so you'll have to, I think, when you run the install script, Docker gives you a particular command to run, and so you have to copy and paste whatever that particular command is. If, for whatever reason, any of these environment variables somehow get changed to something that you don't want them to be. So for example, we've changed the PS1 environment variable manually in the terminal. If I want to reset it to what it was originally, I can just copy and paste this line right here back into the terminal to get it back to what it used to be. I can also do what's called sourcing the bash RC file. Sourcing the bash RC file. When you source a file, what that means is you run the file, but you run it, sourcing literally copies and pasting. Sourcing literally copies and pastes the lines of the file into the terminal. So we've seen before that I can run a shell script by doing something like sh.bashrc rc. Bash rc is a shell script. sh.bashrc will run that. And it's a bash file, so I have to do bash.bashrc. Recall that sh is a strictly POSIX compliant shell. On the Lambda server, it's called the dash shell. Bash RC is a bash script, has some non-POSIX commands, and so bash.bashrc runs it. But this did not actually change my, my prompt again, because this is running in its own separate process, its own sort of little containerized space, and environment variables in children processes. This is a child process of my current terminal. They do not affect the parent processes. And so in order to actually have those environment variables take into effect, I have to source the file, source the bashrc file instead of running the bashrc file. And you source a file by using the command, just a period by itself. So it's period space dot bashrc. Do that. And now that reruns the bashrc file, and I'm back to having my previous PS1 prompt variable. Covered a lot of different subtle things in there. If any of that didn't make sense, that's okay. It's not, none of that's required information. As long as you can get the Docker command running, then you're good to go. And I'm happy to meet with people one-on-one after class or at other times to make sure that Docker is working for you. But at this point, are there any questions about any of that? Yeah, Matthew.
What if we didn't copy and paste the Docker command that you put in the bashrc file right when you installed it?
That's a good question. So the question is, if you've installed Docker, but you have not set the environment variables. The answer is that when you, so the situation is Docker is installed, environment variables not saved into .bashrc. The bashrc file is run every time you log into the Lambda server, basically anytime the bash command gets run. Recall that the RC stands for that runcom shell from back in the 60s. And in general, any file that ends in RC is like a configuration file for whatever the name of the program is that comes before it. And if you have not saved those environment variables into the bashrc, then Docker will work the first time that you're in the terminal immediately after installing, but Docker will not work after logging out and back in, because Docker needs those environment variables to be set. If for whatever reason you forgot to or didn't update your bashrc file, then you can always just rerun the install script and it will tell you what those environment variables are, and you can then copy and paste it into the bashrc file. Did I answer your question, Matthew?
Yeah, thank you.
Perfect. Any other questions so far? Great question. Okay, so I'm going to switch my screen over to our class repo so that we can talk about, oops, that's not what I wanted to click. There we go. So we can talk about our just high-level notes about Docker before we dig into the technical details. As a reminder, there was some pre-lecture videos for today. Again, the purpose of these videos is to sort of give you a little bit more cultural background about whatever it is that we're covering in class, and so you probably won't necessarily need to watch them in order to get an A in the class or get 100% follow along with everything that we're talking about, but they're the kind of things that just educated, well-rounded computer science people know. So, Docker. Why use Docker? Docker is used everywhere, and we saw this StackShare website on the first day of class, that if there's a particular technology, you can go to this website and it tells you what companies are using Docker. Basically, every company that you've ever heard of that is a tech company is using Docker. More than 8,000 major companies are using Docker. So ones they have listed, things like Pinterest, Shopify, Spotify, Udemy, Twitter, but also Google, Facebook, Microsoft, all of these major companies, all 100% rely on Docker. They would not work without Docker. So why is Docker used everywhere? It solves this really important problem that you may have encountered in previous classes. So different computers have different versions of libraries installed. And so if you write your code on one computer and it works on your computer, it's not necessarily going to work on a different computer that has different libraries. Docker lets you, and in particular, a Docker container lets you package up all of these other libraries that your code depends on into just one tiny little thing. And so you deploy not just your code, but also all of the libraries and everything that your code depends on. And so that if it works on any machine, it's guaranteed to work on every machine. So there's this common phrase that it works on my machine. I don't know why it's not working on your machine. But now that we have Docker, you should never say this phrase that it works on my machine anymore. And in particular, so it works on my machine. So let's just, whenever we're distributing things, we'll actually distribute your entire machine to everybody else. That's the basic idea. And that's how Docker was born. Quick downsides of Docker is that there's a lot to learn with using Docker, and in particular, a lot of concepts that sort of work together, and it's not necessarily going to make sense why things are the way they are until you understand the entire big picture. And we're not even going to have a chance to talk about the entire big picture until probably the end of next week. So we have another several lectures that are going to be talking about all of this and how it all fits together. And then it might even take you until the end of the semester before things start to feel natural for you. If Git and GitHub, those systems felt a little bit confusing to you, then that's totally normal. They certainly did to me when I learned it. And Docker also certainly felt even more confusing to me because it's sort of like Git on steroids in terms of the complexity and power. So again, the things that we're talking about today, if you don't understand all of the technical details, nitty gritty, that's okay. As we're working, try to get the big picture of what's going on, and it'll really be the labs and homeworks that you work on that'll cement things. You have to actually use these commands, run into errors, resolve those errors, and that will help you out. So two sort of important references, this idea of what a container is. A lot of people talk about the difference between Docker and virtual machines. We're not going to talk about that at all in this class. That's something that an operating systems class would go over in detail. But know that people will, out in the wild, out in the real world, make fun of you if you are confusing the difference between a Docker container and a virtual machine. This other link right here is really the actual useful one in the sense that this has example commands and explanations about what those commands do. So there's another thing to just read through, go over if the things that we talk about in class today in the next couple class sessions don't make sense. Check out this link, and this is sort of like the textbook for the next couple of lectures. And the really important thing in this link, scroll down a little bit, is this image right here. That if you can understand what's going on in this image, then you are good to go. That should be your goal for the end of this week, is understand this image. And so the remainder of this class, we're going to go over the different Docker commands, and we'll relate them back to exactly what's going on in this image, and probably won't fully finish that today, and we'll finish that on Friday. Okay, so, well, let's see. The big picture idea here is, so client over here, this is like your shell. And your shell happens, in this case, to be existing on the Lambda server, which is also the Docker host in our current setup. They don't have to be on the same machine, though, and all of the commands that we're going to be working with, they just by changing one of your configuration settings, rather than working on the Lambda server, it would be working on AWS or Microsoft Azure or any of these cloud systems. So all these cloud systems are built with Docker in mind and allow you to really easily deploy your Docker systems to the cloud. And then this registry is something that is not on the Lambda server, but it is a place just out in the cloud, some other portion of the cloud that contains information that we can download. This registry is sort of like GitHub in that it has things like repositories that we can download and work with. And let's switch over to the Docker terminal, or sorry, the actual terminal here, and go over some of these commands. Again, I'm resetting what I'm working on, my thought process. I want to clear my mind, refresh my my thoughts, and so I'm going to type the reset command here in order to get a clean slate. Let's see, again, the first command that you'll want to type into your system for Docker, just to make sure everything is working, is docker ps like this. And if you get an output that looks like this, that means that everything is working correctly. In order to start a Docker container, I'm going to do this docker run command. And then the thing that comes after run right here is the name of a container that I want to start. And we'll start by doing docker run ubuntu like that and hit enter. And you can see that we have this unable to find image locally. Ubuntu, did I spell things correctly? Sorry. Let's see. So instead of doing docker run, let's start with docker pull ubuntu to download this Ubuntu container. Next time for Ubuntu does not exist. It may require docker login. This is not supposed to be happening right now. Let's see. Maybe one of the advantages or disadvantages of me doing live programming is that sometimes the things do not turn out exactly the way that I'm expecting them to, and that's what's going on right now. So we get to see a little bit of live debugging as I figure out real quick what is going on. Unfortunately, probably don't have enough familiarity with Docker for exactly all the things that I'm doing to necessarily make sense, though. Okay. I'm not sure.
Mike, is it a typo on Ubuntu?
Yes, it is. There's an N there. Thank you. Docker pull Ubuntu like that, or Docker run Ubuntu like that. So the docker pull command is sort of like the git pull command or the git clone command in the sense that it pulls something from the Docker repository and puts it on your local computer. What the pull command downloads what's called the Docker image. And the image is one of these key vocabulary words that's going to come up over and over again throughout the semester. And I'm never going to test you on the image, like what this is, a formal definition, but you'll want to get an intuitive sense for what it is. And basically, it's a blueprint for a computer, everything that we want to have inside of a computer. The Docker run command actually runs one of these systems. And for this particular computer, there's basically nothing installed. So when we do Docker run Ubuntu like this, basically nothing happens. In order to actually make something happen, Docker run -it Ubuntu space bash is a command that will run here. And the -it, anytime that you're working with something sort of interactive in a Docker shell, it'll be Docker run it. And then the name of the image that we're working with and the command that we want to run on that image. Here, I'm using bash, so that shell command. And it started up this whole separate computing environment inside of Docker that I'm now inside of. And if I do this who am I command that we've seen before, you can see that I'm no longer logged in as my Lambda server account. I'm logged in as root. Again, root is the administrator of a computer in Linux. And so you do not have root access. You don't have root access to the Lambda server, but you do have root access to all your Docker containers. Currently, so the image is like the prototype of a container. It's the thing that tells me like what commands are going to be available on the container. The container is the actual thing that's running. So I'm currently in the container. And we mentioned before that in the prompt, one of the common, so like the $sign is commonly used to indicate like this is the prompt for a normal user, and the hashtag commonly used to indicate that this is the prompt for a root user. So I'm currently logged in this container as root. If I do something like Python 3, Python 3 is not available inside of this Docker container because it hasn't been installed. But we exit out of this Docker container back on the Lambda server, I do have access to Python 3 on the Lambda server. So inside of this Docker container, it's like a whole separate computing environment. And it's very difficult to interact between this computer or this computing environment, the Docker environment, and this normal Lambda server environment out here. Let's go back, do Docker run it Ubuntu bash again, and we're gonna see some other properties of Docker containers. One is that Docker containers are what is called ephemeral. Docker containers are ephemeral. And what ephemeral means is that any changes that I make to this Docker container is only going to exist inside of this current session. Any changes to the container only exist in this current session. And so I'm going to make some changes here. We'll do a really simple, let's do touch file 1, 2, 4. I skipped 3 on accident. Type ls. And so we can now see that inside of the root folder, pwd, I'm in the root folder of this Docker container. There are these 3 files that I've just created with this touch command. And these files are only going to exist in this one individual Docker session. If I type exit, leave this session, and then go back into a new session, type ls, we can see that those files have disappeared. They don't exist anymore. This is both one of the big limitations and the big advantages of Docker. It means it's a limitation because it's hard to control state, hard to remember files, but a big advantage because it means that deploying these systems is going to be really easy. We always know that if we deploy this Ubuntu system, it's going to exist out in the wild in its fresh, pristine state, no matter what. So this begs the question of how can we create Docker containers that have like important things inside of them? So we saw, for example, like Python 3 doesn't exist inside of this Ubuntu container. I can install Python 3 using the apt-get command. In order to install programs inside of Ubuntu, it's a two-stage process. You first do apt-get update, then apt-get install, the name of the command that you want to install, the name of the package. So in this case, Python. So this is the, I didn't run these commands yet. It started with a hashtag, so it's a comment, just so that you can see what the commands are gonna be. They're gonna have a lot of output. Do apt-get update. This is just contacting Ubuntu, asking what are the latest versions of all the packages like Python that are available. And then I'll do apt-get install Python, fix my typos, and this is going to install Python. And you can see it'll add 30 megabytes of disk space that will be used. There's another one of the sort of mild drawbacks of using containers is that if we have, say, 100 containers running in on the Lambda server, each with Python installed, then we'll have 100 different installations, separate installations of Python. And so they can potentially use up a lot of extra unneeded disk space. But disk space is cheap, especially compared to programmer time. And so it turns out not to be a too big of a limiting factor, not too big of a problem. So I've installed Python, and now here we go. I have access to Python inside of the terminal. I installed Python 2 instead of Python 3 on accident, so that's why this command didn't work, and I have Python 2.7.18. But again, if I leave out of the terminal, or leave out of the Docker session, come back inside of it and type Python, I don't have this command anymore. Any of these changes, any programs I install, any files I create, they do not stick around between sessions. So in order to create usable Docker images, usable Docker containers that contain the programs that I want them to, there's something called a Docker file that we're going to be using in this class. So in order to do this, I'm going to switch my folder into our week 1 folder so that this Docker file that I'm going to create will be something I can upload to GitHub and you'll have access to after class. And anytime you're creating a project with Docker, Docker requires that you put that project inside of a folder. So we'll just real quickly make a folder, Docker example, cd into Docker example, and then vim docker file like this. docker file alias, there we go. And in the Docker file, the format is at the very top. You have the word from, and this is the base image that you plan on using in Docker. So here I'm going to do from Ubuntu because this is like I started with the Docker run-it Ubuntu bash command. This right here, this Ubuntu corresponds to this Ubuntu right here. Escape, save that, and then I can add what are called run commands in the Docker file. Each of these run commands is like one of the commands that I typed into the terminal in the Docker container that we were using. So I type run and then apt-get update like this. So I ran this apt-get update command in the terminal, and here I'm running it again in right here. So this command gets run inside the Docker container. And then there was another command that I typed in, the apt-get install Python, and like this. And this command will also get run to install Python for us. I'm going to go ahead and save out of this. So here we have the Docker file. And then I'm going to use what's called the Docker build command, Docker build. and then I specify a directory that it is going to build. Dot refers to the current directory that I'm in, so this directory right here. And Docker will look for a Docker file specifically named Docker file inside of that directory and follow those instructions. So docker build dot from requires either 1 or 3 arguments. So vim Docker file. Inside of Docker, the hashtags are comments, but the comments must be on a line all by themselves. So that's why I was getting an error message. I'll change that to these commands. This get run inside the Docker container. Maybe since I'm in Vim right now, I'll show you a quick Vim shortcut. I have this S over here that I want to delete, and my cursor is way over here on the left. I could use, say, the right arrow key to get all the way over there, and that's maybe like 20 or 30 buttons to press, so that's kind of annoying. A little bit faster is I could use the W command over and over again to jump over one word at a time, and then use the arrow keys to get over. It's a little bit better, but still a little bit annoying. The best way to get to where I want my cursor to be in this case is to use the F command in Vim. The F command. F stands for find, and it lets me find a particular character on the line that I'm currently at. So I type FS to find the next occurrence of the S character, and then I type the semicolon to find the next one after that. So it's only 3 commands that I type, and I get to the exact location that I want. And then I press the X command to get rid of that S. So all I had to do was type fs semicolon x, up here fs semicolon x, and I got to the exact spot, deleted what I wanted. Super efficient, really easy to do once you've sort of internalized this this way of using Vim.
Hey, Mike.
Yeah.
Is there a way to skip to the beginning of a line similar to like Shift A, like skips to the end of the line?
Good question. So the question is about line movements. So Joey mentioned the capital A command. Capital A moves us to the end of the line and enters insert mode. Down here, you can see that I'm in insert mode, not in normal mode. Press escape to go back to get into normal mode. If I want to go to the beginning of the line and enter insert mode, Shift I goes to the beginning of the line and enters insert mode. So A, end of line, insert I, beginning, insert. But usually these insert commands are not what I want. I want to move my cursor without entering insert mode, staying in normal mode. The 0 takes you to the beginning of the line, like the 0th column, without entering insert mode, staying in normal mode, and the $ takes you to the end of the line without entering insert mode. So 0, beginning, $ and staying in normal mode. Again, I remember these as, so A is for append, so append to the end of the line. I is for insert. By default, if you want to insert, you probably want to insert at the beginning of the line. 0 takes you to the 0th column, and $ is the regular expression for end of the line. So once you get the hang of these are real good shortcuts to have in your toolbox. But again, this is just like a good things to know, not things that you need to know. The meat of this document is the things that are most important, things that you must know for the class. And it's also a great question. As we're working throughout this class, I'll be opening up Vim and showing various Vim tricks to make you more productive. Similarly in the terminal, various terminal tricks to make you more productive. You should always feel free to stop maybe the main content of the discussion. We can go on a tangent about productivity for a little bit, and then get back to the main discussion after that. And this is, again, one of those things that at, say, like a technical interview with a job, if I am like watching somebody program and they're using Vim and they're using these like shortcuts like this, I know they're a good programmer. I don't have, it's like an instant hire. I don't have to think about anything else, because the only people who take the time to use Vim and use these shortcuts are the people who are careful, care about their code, and are good programmers. The people who, people who don't have those things mastered, it's not necessarily a sign of being a bad programmer. But if you have those mastered, it's just a clear, obvious indication to other people you're working with that you're going to be a good, productive member of the team. Okay, so yeah, again, Docker file from Ubuntu. This is the name of the base image up in the Docker repository that we're downloading from. And then the run commands are the commands that are actually getting typed into the terminal to make things happen. Control, WQ, save and quit that. Up arrow, up arrow. Docker build dot is the command that we're running to build the Docker file. This dot, again, is not something that is specific to Docker at all. It is the general name of the current working directory, the folder that you are currently in. So in this case, the Docker example folder. And you always, after build, must specify a folder that Docker will use to as the template for building the Docker image. And so Docker build dot is the common way to do this, because you'll commonly be inside of the folder that you're working with. And if you look carefully at the output from Docker build dot, this will look familiar from the output of the commands that we saw when we were in the Docker container that we created with the Docker run command. I'm going to bring up the old command using the Control-R shortcut on the terminal. Control-R, again, lets me search through my bash history and type in Docker run. So Docker space R. This is just enough to for it to uniquely identify the command that I typed in before. And there we go. So when we're doing this, hit enter, and I did things like apt get update. This output right here is the same output that we were seeing up above. But now I can directly run a Docker image, a Docker container created from this image up here. And in order to do that, I can use the Docker run command again. Docker run. I'll use -it again, but now instead of using Ubuntu right here, I'm going to use this sort of crazy hash right here. The very end of the Docker build command gives me the name of the container, or the name of the image that I just built using the build command. And since I didn't specify a name manually, it gives me this randomly generated name right here. So this matches this right here. Docker run it that, and then let's type bash again. I'm inside of this Docker container down here. Again, who am I? I'm still root, but now if I type Python, I have access to Python, and I can do whatever Python things I want to do. Hello world, like that, print hello world. So again, the main takeaway, Vim, Docker file. The Docker file is a blueprint of all of the commands that you should run in order to get the same system that is has all of the libraries needed to make your code work. Talked about a lot of different technical things so far. Again, it's okay if it's not 100% making sense to you. But at this point, are there any questions that people have that we can go over?
Mike, so once you build that container, do you need to, like, if you don't want to have that container built anymore, do you need to run a command to like take it down?
This is a great question. So here we've done two things so far. We've created Docker containers and Docker images. So Docker build creates an image, Docker pull downloads an image, Docker run converts an image into a container. The exact differences between images and containers are, again, slightly subtle, but the image is the blueprint for the container, and the container is the actual like running sort of virtual machine, running computer. And so we'll only have one of these images and one of these containers at any given time. These containers and images are both using up disk space on the Lambda server. In order to see how much disk space they're using, I'm gonna come back over here into our notes, and down at the bottom, there are these debug and admin commands that I have listed down here. And this Docker system command is sort of the most important, that it'll report how much disk usage Docker is using. So I can do Docker system df like this. df stands for disk free. So that's why it's df. Hit enter, and it'll report so how much my different images and different containers are using up. You can see that I have a lot of space being occupied by images right now because I have actually all the images installed that the class needs on this account right now. Not a lot of space is being used by containers, just 100 megabytes or so. If I want to free up the space used by containers, then it's the Docker ps command lists all of the currently active running containers. In order to see exactly what that means, let's do a Docker run command like this. So this is going to run a container, hit enter, and I'm currently running this container right here. Notice that if I type Docker ps inside of the container, this will not work because I'm inside of the container. In order to run this Docker ps command, I have to be outside of the container. In order to be outside of the container, I'm going to start a new terminal. So on my machine, I have it set up that I just have a shortcut for starting a new terminal. I can do Control-R user test like this to get to my SSH for logging into my user test account, and type in my password. Let's go ahead and clear the screen, and then do Docker ps from the other terminal over here. I also have shortcuts on my window manager, the thing that I'm using, like your interface to your desktop, to automatically shift my screens around. I'm usually, when I have multiple, I don't know, depending on exactly what I'm doing, sometimes it's nice to have them side by side, sometimes it's nice to have them split this way. When we have extra long output on our commands, this type of split is particularly nice. And so now both the top terminal and the bottom terminal are logged into the Lambda server. The bottom terminal is also logged into a Docker container with this Docker run command. And up here you can see this Docker run command actually running up here. At this point, we've only created a single one of these Docker containers running by itself. By next week, we're going to be creating about a dozen or so of these Docker containers that will be working together to serve your own version of Instagram. So that you'll be, yeah, that's sort of what we're building up to with Docker right now. There's an important command from the terminal up here. If I type Docker stop, then I can use Docker from the Lambda server to exit out of, stop this Docker container down here from doing whatever work it's currently doing. Previously, I've exited this Docker container using the exit command. In order to use the Docker stop command, I have to specify the container ID that I want to stop. I'll do Docker stop space and then this number right here, hit enter, and you can see that that terminated this Docker container session down here. Now up here, if I type Docker ps, then there are no longer any actively running containers listed. There are still a number of sort of hidden containers, and so this is finally getting to the answer of Joey's question. A number of hidden containers. All of these containers are things that I've created in the last few minutes during lecture here that are still eating up the disk space on my computer. So if I do the Docker system df, it's listing as the containers down here eating up 100 megabytes. Docker, the Docker container command lets me manipulate all of these containers. The Docker rm command lets me specifically remove them. And the prune removes all of the stopped containers. So Docker container prune. Are you sure want to continue? Remove them all? Yes. It's going to delete all the containers. It lists their hashes up here that have been deleted down here under Docker system F. If I rerun it, you can now see that the containers is taking up no space at all. There's a similar command for the images that could free up this space up here as well. Throughout this course, as you're working on your labs and your homework, you're going to be like building up lots of these containers and images, and you'll be needing to delete some of them in order to make space on your accounts at different times. And so these Docker system df, Docker container prune commands are the things to keep in mind for that. And again, those are reminders for that down here.
Mike, sorry, quick question about Docker system df. Is that just for your account on the Lambda server, or is that for the entire Lambda server?
It was a great question. So because we're using this rootless Docker system, all of your Docker installs are 100% isolated from each other and have no knowledge of any of the other Docker installs that are going on. Down here on the bottom terminal, I'm going to type cd to get myself back to the root folder, type ls-a so we can see all of the files, not just the hidden files included, not just the normal files. We've seen there's this .ls or this .local/bin file before that contains all of the executables that I've installed just for myself that are not related to other people's systems that nobody else can find because they're in my home folder, my .local/bin folder. And so here's my Docker, various Docker commands inside of here. Inside of this .local folder, ls.local, there's also a share folder. And share is where sort of programs just put things that needs to be shared between multiple versions of the program running at once. And so we have .local/share/docker, and this is where Docker stores all of its images and containers and the things that you create with the Docker command. So this is inside your home folder, only taking up space on your machine and independent from other people's machines. Again, if you're feeling a little bit overwhelmed by all of this Docker stuff that we've talked about so far, that is an okay place to be. This is a complicated system, and I certainly felt very overwhelmed by it when I was first learning it. Eventually, these commands become second nature to you, and but part of the thing that needs to happen for that is that you just need to get exposed to all the different powerful things that Docker can do, and we'll continue doing that over the next lectures. And then once we've done that, things will be slowly starting to click together for you. So at this point, your goal should not necessarily be like memorizing all of these different commands and fully understanding exactly what they're all doing individually, but getting this big picture sense or big picture idea of what they're using, what they're doing. That is everything that we'll cover as part of lecture today. I have my office hours after class. I'm happy to stick around and answer any questions that people have about this or anything else. But otherwise, I hope you all have a good rest of your day, and I'll see you on Friday. Anybody have questions? Dustin?
Yeah, I just have a question related to installing the Docker packages.
Yep.
I'll share my screen. So I'm having trouble. It says like the Docker packages don't exist in this file. So I moved it to the .local